All right, I better get started. It's time to go. Good afternoon, everybody. Welcome to a wonderful pre-July 4th meeting or lecture or whatever, a fun time of organic chemistry, Chem 170, with me, your host, Dr. White. Now, a couple things I want to remind you. A week from today will be test number 2. And give me a second. I should have done this earlier, and I didn't. Bad Dr. White. I'm logging into D2L. I'm opening D2L. And thumbs up, people. Do you see Chem 170 test number 2 information? Thank you, all of you. All right. Remember, on next Thursday, the 8th, I will be giving test number 2 online, just like we did test number 1. And it will cover, as 9 pages, 10 problems. It will cover alcohols, thiols, ethers, reactions of ethylene oxide, and aldehydes and ketones. Now, the breakdown will be 11 points, general knowledge, nomenclature 34, and reactions 60. And remember, nomenclature, there are 2 main problems. I asked for nomenclature, and that is, here's the structure, give the IUPAC name, and then here's the name, both IUPAC or common, draw the structure. Reactions, the bulk of these 60 points will be give the organic product or products, excuse me, and a couple of them will be give the starting materials to make that. I will do a review on Tuesday for test number 2, and on that Thursday, we'll still have our regular Zoom meeting. And that's test number 2. Any questions about test number 2? All right. I mentioned it's harder, so make sure you do the practice problems. Plus, bonus today, we're ahead of schedule, so I can actually, this normally happens face to face. I'm going to spend some time today. Thank you for turning on your web camera, those of you who do. And I will be doing later today, after we do the ethers and epoxides problem set, having taught this class a number of times, on test number 2, there are certain areas students always have problems with. And a couple of years ago, I started right before the test doing some more practice with you. And we'll do that today. And afterward, we will get back to carboxylic acids. Now, let me remind you, notice patriotic, this coming Monday, there's no class, none. You can all go, yay. By the way, if you suffer Dr. White withdrawal symptoms, you can always go to my YouTube channel. But anyways, there's no class because ECC is closed technically, not technically, actually, because the July 5th is part of the long July 4th weekend. Yay. Anyways, we won't have any class that day. However, because there's a test coming up, I will still have my office hour. Just don't tell anybody I'm being nice and doing that. And it will be from 5 to 6. If you need me to stay a little longer, I will. But it will be from 5 to 6 on Monday, even though there will not be a lecture. But if you need some help, because test number 1 is stop by. And because it's the 4th of July, I've got to do the following, or coming up to being 4th of July. Time out for commercial.
Is that?
Everybody see the fireworks? I hope you all enjoyed my 4th of July or pre-4th of July little gift to you. Back when I was a little older than you are now, that was a while ago, myself and a couple of friends, if you have noticed, Dr. White's not small, we're all big. We'd go down to downtown Chicago. That's before they had the opera, the music synced with the fireworks. It was just fireworks. And by the lake, and it was really good. And I also went to Evanston. I'm a North Sider. I was raised in Lincolnwood. If you don't know where Lincolnwood is, it's in between Skokie and Chicago. That's Lincolnwood, tiny little place, very nice. But anyways, I thought I'd share that with you. All right, let's get to work. Thumbs up, people. Do you see ether epoxides problem set? Thank you. All right, let's go through a couple of these. And first one, give the organic product or products for the following. If we look at B, what's different? Remember, look at a molecule and look for what's different. What's not carbon, what's not hydrogen, and what's not a carbon-carbon single bond should get your attention like this. Shh, don't tell anybody I'm giving this away, but for test 2, look for oxygen. Look for oxygen. That's going to be where the fun is. Shh, don't tell anybody I helped you out, okay? And if we look at B, oh, there's an oxygen with a negative charge on a carbon and a sodium cation. That's an alkoxide. Oh, halogen. That's an alkyl halide. That should have been R prime. My mistake. And you get an ether plus a salt. We don't have to put down the salt because I'm asking for the organic product. What's R? The cyclopentane ring. What's R prime? This isopropyl group. The oxygen here, the O minus, bonds to the carbon with the halogen in the ether. And therefore, this is ether you get. And if you notice, same thing in C, R is ethyl, R prime is ethyl, alkoxide attacks the carbon with the halogen, in this case chlorine, and you make diethyl ether. Now, again, look for what's different. Oxygen. Ooh, carbon-carbon oxygen, and alcohol. Ooh, three-membered ring, two carbons oxygen, ethylene oxide. General reaction is you get an ether alcohol. This opens up the ring, the OR from the ether attached to one carbon, and the H from the ether opens up and goes on the oxygen from the ethylene oxide. In this case, R is 4 carbons. There you go. Here, R is this ring with 2 methyl groups attached to oxygen, CH2, CH2OH. And that's how you do it. This reaction with epoxides or ethylene oxide, I will never put a synthesis problem on a test or a final. That's cruel and unusual punishment. I don't do that. And here I just did a big, ugly, scary R group. Not really. O, CH2, CH2, OH. Now, here I have a benzene ring, but it's really, this won't react with a benzene ring, but it will react with an alcohol. Notice I have the number 9 as the coefficient. Excuse me, that's the number in front that tells you how many molecules and moles. And before it was this 1, now 9, we have a different reaction. Here, alcohol with N moles of ethylene oxide, you make this polyether alcohol. Don't forget the brackets and the subscript N. What's R? Benzene ring. What's N9? So I have my benzene ring to the OCH2CH2 in the bracket, subscript 9, and the hydroxyl group is on the outside. Listen closely. Common mistake, students put the hydroxide inside the bracket. Wrong. It doesn't go inside. No such thing exists. It has to go outside the bracket like I have there. And here I give you another example with a different R group. What is N5? R is CH2, 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 bracket O, CH2, CH2, close bracket, subscript 5. And notice the hydroxyl group is on the outside. Now, before I forget, problem C, cross off. I'm not going to give a synthesis. I just got carried away. I was having way too much fun, but do not worry about problem C for any reaction with ethylene oxide. And actually, I got that wrong. There should be a 4 in front. I will not put on test. But let's look at B. What 2 things do you react to make this molecule? Plus, ooh, a salt, sodium iodide, NaX. Remember, whenever you say halogen, bromine, chlorine, or iodine, Cl, Br, or I, we use the letter X as a variable. Just like R or R prime, anything with carbons and hydrogens. And what's different here? Ooh, an oxygen. And what does that mean? Carbons here around an oxygen, and you have an ether, and also the salt. X in this case is iodine. How do you make an ether? Alkoxide, RO minus, Na plus, plus an alkyl halide. Now, I could have said the N-propyl is R and the isopropyl is R prime, and that would give you the top 2 chemicals reacting. Or I could have said this N-propyl is R prime and the isopropyl is R, and then the bottom 2, which are right, both. Either one would be correct on the test. Well, that was a quick problem set. Any questions about ethers and epoxides? Oh, that reminds me. Uh, Something I did that I shouldn't have. Oh, I got a feather in there or something. I hope not. No, I didn't eat any birds. But anyway, oh no, it's awful pre-holiday humor day. But anyways, when I started in industry, I was very fortunate to have a mentor at the company I started with. I was just out of academics, postdoctoral fellow. That was Mr. Sid Shapiro. And Sid was my mentor. I was in my late 20s, 27, I think. And Sid was probably almost 70, maybe a little older. And in a couple of years, he did retire. But Sid had a great career at that company, it was AXA, and he was my mentor. And we actually carpooled for a year till uh, he got transferred downtown and that stopped. And during that carpool, 40 minutes each way, he quizzed me and taught me a lot. One of the things he always beat into my head was never assume or you become the first three letters, which is true. And guess what I've done with you? I've assumed something, so let me correct that assumption that I shouldn't have made. Oh, excuse me. All right, thumbs up, people. You see my Chem 170 channel? Let's open one up. Ooh, there's a nice looking guy there. All right, if you look here, you see.
Good afternoon, everybody.
I'll let you
Welcome
do it.
to
Oh, that sounds familiar. All right, you see the title, you see the date, and see where it says show more? If you click on that, notice I have the topics for each of the videos. In case you weren't aware of that, you are now. Each video I post, all the topics I cover. Well, I covered a lot on the 29th, but each one shows this, and that will help you find the videos you're looking for. Also, the date and the week, you can look at the syllabus, and I'm pretty much on track, maybe a little bit ahead. So I just wanted to make you aware of that. If you weren't, let's do another one. If we hit show more, notice yesterday, yeah, I did do the alcohol problem set. We did nomenclature, carboxylic acids, and we also did the ketones and aldehydes lab. And now I feel better because I'm not assuming you know to click on show more. Now you do. All right, let's try something. Since you just did some ethers, and give the organic product or product for the following 3 points each. Everybody see that on their screen, the whiteboard? Thank you. When you're done, give me a thumbs up. All the millions of you out there. All 5 of us today. Well, like I said, this is an internet course. If you look at how many views people watching my YouTube videos, I'm a YouTube star. Look out. All right, anybody need more time? Nobody's yelling. All right, let's look at this. What's different? Ooh, oxygen. with carbons, and the oxygen has a minus sign, and we have a cation, and that is an alkoxide. I'll never ask you what it is, but that's what it's called. And we come over here, carbon, halogen on a carbon, alkyl halide. Remember, for this reaction, X can be chlorine, bromine, or iodine. And this is a Williamson ether synthesis. This attacks the carbon with the halogen, bonds to it, and you form an ether plus salt. And now, this is my R group. This is my R prime. And the carbon with the halogen is the carbon this oxygen will be bonded to an ether. So I have my R group, oxygen, my 3 carbons. Remember, do you break carbon-carbon single bonds? No, and I didn't. And that's the product you get. And why don't you try this one? What would be the 2 things you react together to make those products? I see one person done. Doesn't that feel good? You can do this stuff. And hopefully it's not hurting your brain. It was interesting. In my other class, a student logged in. I saw a phone number. I said, I bet they lost power. And sure enough, he lost power. He called in on his cell phone to listen to my Zoom meeting. But anyways, let's get to work. What's different? Oxygen. Remember, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like, oh my, there, it's working again. All right, what do we have here? Carbons here, carbons here. It's an ether. And I've got a salt, NaX. Did I ever tell you, if you ever go out with a bunch of chemists, like I've done this, you know, table salt is sodium chloride. And then one of us will always ask, could you please pass the nickel? You can smile even at bad jokes, but that's true. All right, how do you make an ether? An alkoxide plus an alkyl halide. I can call this R and this R prime, and this is my X. Again, one of the groups of carbons on the oxygen, I'll call R, the other one R prime. If that's the case, R is ethyl, so I'll get this alkoxide. R prime is N-propyl. Notice the N carbon is attached to the oxygen. And I will get this, what's the halogen? X is iodine. And the carbon that was attached to the oxygen, which is this one, will have the iodine. But wait, I'll go this color. What if I call this R prime and this R? Well, in that case, R would be this. The carbon with the oxygen, R still has it, but it's an alkoxide. And R prime would be this. And the halogen is still iodine. Now, which is right? A or B? And the answer is both. Either one would give you that product and be correct on my test. And why don't you try this one for your fun and enjoyment on this Thursday afternoon? By the way, keep your fingers crossed. Tomorrow I'm having a lot of tree trimming done, a couple of trees cut down that were really weed trees I should have gotten. They got too thick. I have to have someone in to do it on my property. I see one person, Dawn. Take your time, the rest of you. All right, everybody done? Let's take a look at this. What's different? Remember this chapter, look for oxygens. Oh, look, an oxygen with a hydrogen on a carbon and alcohol. Ooh, carbon, carbon, oxygen, ethylene oxide. And what happens? You get an ether, alcohol. And what's our N-propyl? 3 carbons. Which carbon has the hydroxyl group? The end one. And therefore, that will be attached to the oxygen, CH2, CH2, OH. And some of these products either go into cleaning products, like I talked about, oven off, easy off oven, I think is cleaner, and also other things, including cosmetics and personal care. Oh, let's do one more. These are fun. And what if you reacted these two? What would you get? If you're drinking something nice, you got to share it with the class. No, I'm just kidding. When I teach face-to-face, I tell students, because usually when we teach face-to-face at ECC, 170 starts at 1. I say, you can bring anything you want for lunch as long as it's legal in the state of Illinois, the city of Elgin, and our campus. And it doesn't make too much noise when you're crunching on it. All right, let's do this. What's the product or products for the following? Ooh, oxygen with a hydrogen and a carbon, that's an alcohol. Remember the rest of this carbon, hydrogen, this carbon, carbon, single bond, it's gonna come along for the ride. Ooh, the number 7, and I'll use that, and ethylene oxide. And what do you get? You get a polyether alcohol. And what's R? This right here. What's N7? So do you break carbon-carbon single bonds? No. So I have my ring, I have my methyl group. The carbon with the hydroxyl group, alcohol, is attached to this. What's N7? And then make sure the hydroxyl group goes outside the bracket, not inside. And that's how you do it. And that's our ether alcohol practice and problems. That any of you have questions about ethers or epoxide chemistry we just did. Look at the chat down there. I don't have to go like that. Just
Yeah, can you do one more example
of what?
of like the problems you were just doing?
The ones I just did?
Yeah, like the last one you just did. Can you do another one?
The one with the 7 in it?
Yeah.
And the answer is, of course. Oh, time. Do I have time? I think I still have the picture. I used to work for 2 Anglo-Dutch companies at separate times over a decade and a half. And the first time I worked for this one company, and I'd go over to the Netherlands, and I'd be there for a couple of weeks. First time I was there, on the weekend, I had some time. I was going from The Hague, Den Haag, to Amsterdam. If you've never been to Amsterdam, you're missing a good time in life. I mean, it's good. I used to tell people, you know what it means if you're not having a good time in Amsterdam? You're dead. It's impossible not to. But anyways, I was coming back from Amsterdam. You had to change trains. And sometimes in Amsterdam, they have a magnificent, probably the best train system in the world. They're one of the best, and still is. It's the most heavily used, I think, one in the world daily. But anyways, that's a small country. But sometimes they'll have a 4-car train, split it. One part goes to one city and the other goes to another. So I was about to get on the train, and there was this classic looking with the goatee in his uniform conductor. And this is classic Dutch mentality. I asked him, and they speak better English than most Americans. I asked him, sir, is this train going to The Hague? And he looks at me and says, of course it is. And that's classic Dutch mentality. I loved it. That's one thing I miss. But anyways, let's get back to Special Request Thursday. And there it is, Special Request Thursday with the following reaction. Give the organic product or products for the following. 3 points each. I'll have to look for that picture. I thought I got a picture of him next to his train, the conductor. Very nice gentleman. I can still remember. Of course it does. All right, I think everybody's done. Let's take a look at this. All right, what's different? What's not carbon? What's not hydrogen? I'm going to say that a lot, but every time I look at a molecule, that's what I do. I've been looking at molecules a few more weeks than you have. All right. Oh, oxygen with a hydrogen, hydroxy group on carbon, alcohol. Ooh, the number 11, I'll call that N, and ethylene oxide. That's what this is called, but I'll never ask you on a test. And what do you get? You get a polyether, poly meaning many, ether alcohol. By the way, that's N. And therefore, what's our R group? A TBO group, one of my favorite. What's N11? So I'll write my T-butyl group. The carbon with the hydroxyl group is the carbon with the oxygen here. It's in a bracket, CH2, CH2, close bracket, what's N11? And outside the bracket, very important, it's hydroxyl group, and there's 4 bonds to carbon, so I can put in the rest of the hydrogen. And there you go. Now, one of the things, oi, no, I shouldn't have had a V8, double oi. I forgot to do something I should have done a long time ago. What if you want to do your own practice problems and you've done all the ones in the set? Guess what? You can do your own. And then you can come to me either after class and show it to me, hold it up to your webcam, or email it to me. And I will tell you if you did it right or not. Now, let me show you how to do that. By the way, this is how I do my practice problems. See the R group here in this reaction? Say you want to do your own practice problem. Think of a number between 1 and 10. Oh, let's pick 3. Do you want it branched or straight? Let's go straight. So 3 carbons, and I'm going to put the hydroxyl group on the end. And then pick a number for N, I don't know, 4. And you've just made your own practice problem. And now you do this, and you say, oh, this is my R, this is my N for this reaction, and therefore the answer is this. And I can ask Dr. White if I did it correctly, and I'll tell you, because I'm an organic chemist, I know these things, yay. And here was 4 hydroxyl group. What if you wanted to do another one? Well, pick a number between 1 and 10. And do you want a ring or not? Well, let's do a 4-membered ring. It's got a hydroxyl group. Do you want to put stuff on there like Dr. White? Oh, let's put an ethyl group here. I could put a methyl or something else. And let's react it with 8 moles of ethylene oxide. I'm going to let you try this one on your own. Go. And when you're done, you know what to do. I've got you all trained. And no, my name isn't Pavlov. Everybody understand that bad joke I just did? And you're not dogs either. Even though I have been secretly doing something to you, which I'll tell you about. All right, let's do this. How do you do it? Look for what's different. What's not carbon, what's not hydrogen. Oh, an oxygen. gets your attention on a hydroxyl group, on a carbon, everything else, carbon-carbon single bonds and carbons hydrogen, alcohol. Ooh, I have 8 of something. I'll call that the number N, ethylene oxide. And what do you get? You get this polyether alcohol. What's my R group? This right here, my ring with an ethyl group. Which carbon has the hydroxyl group? That one. That will be bonded to O, CH2, CH2. What's N? 8. And then remember, outside the brackets is your hydroxyl group. And that's how you do that. Now I better let you know in on a secret of mine. One of the things I've been training you this whole semester, and I think most of you are getting it down good, I hope so, we'll find out next Thursday, is look for the functional group. Everything else is just something coming along for the ride. And when I look at a molecule like this, I just see this. Everything else I know is just coming along for the ride. And I've been training you to focus on molecules to find where the functional groups are, because that's where chemistry is going to occur. See how sneaky Dr. White's been? Better watch out for me. All right, don't forget on these, I'll never, with ethylene oxide, give a synthesis problem. Now, this would be a good time. I'm going to start a little earlier. Let's take a 5-minute break, come back at 1:50, and we'll continue on. I'm going to get up and stretch. Oh, I have to. It's time to get back to work, everyone. Also time for me to get comfy in my chair. All right, everybody back? All right, listen carefully. Thank you. Listen carefully. I've been teaching Chem 170 more than once, twice, three, well, number of years. There are certain things on test number 2 students have problems with in ketones and aldehydes. So we're going to do some practice now so you don't have problems and Dr. White's happy because I'm very selfish. I like to make myself happy, and seeing students succeed make me happy. So let's get to work. First reaction. Aldehyde or ketone when R prime. Everybody see my whiteboard okay? Thank you. All right. Aldehyde or ketone when R prime is hydrogen, it's an aldehyde. When it's carbon, it's a ketone, plus an alcohol and acid catalyst. H plus means acid catalyst. What do you get? Keep your eye on the carbonyl carbon. What's attached to it? R prime and R double prime, whether it's a hydrogen or carbons, is still there. This opens up the OH and you have OR. The carbon with the carbonyl becomes this carbon with the hydroxyl group and OR. The oxygen here is bonded to the carbon and R that have the hydroxyl group. I will never give a synthesis problem with this reaction. Your turn, have fun. I hope none of you are getting any Charlie horses or cramps in your thumb from all the exercise. How was that a miserable? Remind me never ever to say that one again. All right, I think everybody's done, but I'll give you another 22.7 seconds. Go. All right, let's take a look at this. What's different? Ooh, oxygen, double bond to carbon. Remember, that's a carbonyl. Carbonyl, oxygen, double bond to carbon. And carbon's here and a hydrogen, that's an aldehyde. It could have been a ketone, but R prime is H, R double prime is carbon. Carbon, hydroxyl group, oxygen again with a hydrogen acid catalyst, that's an alcohol. And what do you get? An acid, hemiacetal or hemiketal. What was attached to the carbonyl carbon is still attached. This opens up the OH on that carbon, then OR. And now what's our double prime? That. What's R prime H? What's R? This. Remember, the carbon with the hydroxyl group is the carbon this oxygen is bonded to in OR, which is this one. I better put 2 dots there. And now keep your eye on the carbonyl carbon because that's where the fun is. And what's attached to this carbon, H and CH2 or CH3CH2 is still there. My general reaction tells me I have a hydroxyl group. What's my oxygen is there? What's our CH2, CH2, CH3? Oh, let's do another one. First of all, for those who want to check, remember I have one of the world's fastest mouse wheel fingers around. All right, let's do one more. And here's one more for you to do. Remember, you've got Monday off class-wise. I'll still have my office hour at 5, but you have it off. And if you go through Dr. White withdrawal symptoms, you can always watch me on YouTube. And I was just thinking at the end of today's class, I'm going to have a special request for all of you who are here today. All right, let's do it. What's different here? Ooh, oxygen, double bond to carbon, carbon's here and here. That's a ketone. Could have been an aldehyde, but it's not. And remember, R prime and R double prime are the carbons in the ring attached to this carbon. And what am I react? Carbon, oh, hydroxyl group, alcohol, and acid catalyst. And what do you get? Keep your eye on the carbonyl carbon. What's attached to it? R prime or hydrogen, and R double prime are still attached to it. This opens up the OH, hydroxyl, OR, alcohol. Anyways, what's R prime and R double prime? It's my ring. Do you break carbon-carbon single bonds? No, so those methyl groups still are there. They come along for the ride. This carbon is this carbon right here. What's on that carbon? OH and O and OR, and this is my R group, which is CH3. Now, if you put the hydroxyl group on this side and the OCH3 on that side, that's okay, because all you're doing is rotating the ring. Remember, molecules don't exist frozen on paper. They rotate just like you and I do. All right, let's move on to the next reaction. And let's look at this one. Now we take an aldehyde or ketone. Remember, carbonyl with a R prime or hydrogen and R double prime. When R prime is hydrogen, aldehyde. When it's carbon's ketone. Ooh, this is interesting. The number 2. You have 2 alcohols with an acid catalyst. Keep your eye on the carbonyl carbon. What's attached to it, carbon or hydrogen, is still attached to it. But now on this carbon, we have 2 oxygens, and each one has an R group. That's why we have the 2. And this is called an acetal or ketal. And I'll teach you when we get into Carbohydrates, Mother Nature uses this reaction to make starches. The good stuff in life that I can't have, potato chips, French fries, pizza. I shouldn't have said that. But anyways, have fun. It's your turn. I see one person's done. Two. Take your time. If you're not done, all right, let's get to work. What's different? Ooh, oxygen double bond to carbon, carbonyl. What's attached to it? Carbons here, carbons here. This is a ketone. It could have been an aldehyde, but it's not. What do I have? Ooh, the number 2. And carbon, carbon. Ooh, hydroxyl group. Remember, look for oxygens, this chapter for test number 2. And that's an alcohol. And I have acid catalyst. And what happens? Keep your eye on the carbonyl carbon. What's attached to it stays attached to it. And now we have 2 oxygens on this carbon that was the carbonyl carbon, and each oxygen has R group. What's R prime? I can call that R prime, and this R double prime, or you can convert it, change the opposite. Either way, it's the same product. Keep your eye on the carbonyl carbon, which becomes this carbon. What was attached to it, R prime ethyl, R double prime methyl. Then I'm going to have my 2 oxygens, and what's R? Ethyl. And that's the molecule you get. I'll give you a second or 2 or 4 to check and see if you did it right. By the way, if you did it right, look up and smile. All right. Oh, let's do one more. Oh, look, Dr. White's having a good ring drawing day. Yay. What would be the organic product or products for the following? All right, I think everybody's ready to go forward. Hold on, I'll give you another 18.7 seconds. That was more than 18. All right, what's different? What's not carbon? What's not hydrogen? An oxygen. It's bonded to carbon with carbons here and here. It's a ketone. It could have been an aldehyde. It's not. Remember, in a ring, our prime and our double prime are connected together. Ooh, two of something. And carbon hydro and alcohol and acid catalyst. And what do you get? Keep your eye on the carbonyl carbon. What's attached to it is still attached to it. Our prime or H and our double prime, two oxygens, and our group on each. What's my R prime and R double prime? My ring. They're disconnected together. So that means this is my carbon, that's this carbon right here. So I'm going to redraw the ring. And still having a good ring drawing day. And the isopropyl group is still here. Think about it. 6 months ago, would you have any idea when I said isopropyl group? Doesn't feel good you're learning? And this carbon right here is this carbon right here. And on it, you'll have two oxygens. What's my R group from the alcohol? Methyl. And that's what you get. All right, now that you made these, what can you do with them? Well, it turns out Mother Nature found a way. And remember, where can you find acid in water? H plus is acid. H2O, I hope you all know, is water in your stomach. I still, every time I think about it, it's a miracle of life that I have and you have cells in your stomach lining that synthesize, that's a fancy word for make, hydrochloric acid, H plus. And we'll learn later in the semester how that actually breaks down your food, all the major food groups, carbohydrates, fats and oils, and proteins. But here, keep your eye on the carbon with not one, but two single bonded oxygens. And what you get back is the ketone or aldehyde that you would have used to make this, in this case, hemiacetal or hemiketal, plus the alcohol you would have used to make that. And remember, what's attached to this carbon right here, in terms of carbons or hydrogen, stays attached and becomes this carbon of the carbonyl. And the R groups come from what's on the oxygen. So oh, I'm working you hard today. Well, you're going to have Monday off, so you'll have time to recuperate. I'm not that mean, am I? Yes, you are. If you're at any picnics this weekend, remember the ethanol in the beer, wine, or hard spirits is an alcohol that's an organic chemical. I see two people done. I think everybody's done. All right, let's look at this molecule. What's different? Ooh, not one, but two oxygens, single bond to the same carbon. And that's rare. There's only two places I know of in all organic chemistry this reaction, the next one we'll practice. And what do I have? Hydroxyl group, oxygen, R group. Then on this carbon, I can either have R prime or hydrogen, which we have hydrogen, and R double prime. And what do you get? What's attached carbon or hydrogen-wise to the carbon with the two oxygens becomes this carbon, carbonyl, carbon double bond to oxygen, plus from here, you get this alcohol. What's our prime? Hydrogen. What's our double prime? Methyl. What's our ethyl? Keep your eye on this carbon. What's bonded to it? R prime hydrogen. R double prime methyl. Carbonyl. Alcohol. What's our ethyl? And that's how you do it. Oh, let's do one more. And here's one more for you to try. That's nicer. Dr. White does quality control on his structures. All right, I think everybody's done. Let's take a look. What's different? Ooh, a carbon here with not one, but two oxygens. One is a hydroxyl group, one is oxygen with carbons on it. I'll call that R. Then attached to that carbon are carbons from the ring, which I'll call R prime, which could have been hydrogen, but it's not, and R double prime. When you react that with acid and water, or water and acid, doesn't matter which you put first, the carbon here with the two oxygens becomes a carbonyl. And what's attached to it carbon-wise, R prime or H, could be hydrogen too, R double prime gives you the ketone or aldehyde you would have used to make that. In this case, hemiacetal or ketal. And you also get the alcohol, which comes from here. So what's my R prime and R double prime? The ring. Here's this carbon, which is this carbon. So I'll have my ring, and this becomes a carbonyl, ketone. And what's my R group? The carbon with the oxygen here is the carbon with the hydroxyl group, so that would be isopropyl. And that's the two products you get. Let's move on. Again, these are reactions students have trouble with on test 2, so I'm giving you a little extra practice. And now if you have a acetal or ketal and react it with acid and water or water and acid, keep your eye on the carbon with two oxygens. Each one has R groups on it. And this is the other case I know in all of organic chemistry, when you have two oxygens that are both, this is important, singly bonded to the same carbon, they both give the same reaction products when you react it with acid and water. The carbon with the two oxygens becomes a carbonyl, and the carbons or hydrogen bonded to it are still bonded to it. Plus you get the alcohol. Now remember, organic chemists, unless we have to, in this case we don't balance chemical equations. But because I had those two twins who got, they get upset. If you want to put a 2 there, I put it real small because you don't really need it, you can. All right, let's try this out. For those who are wondering, it's like I told you earlier today, how do you do your own problems? Well, how many carbons do I want to make R prime? I said hydrogen. How about R double prime 3? How about R2? And that's how I generated that problem. And luckily, I'm an organic chemist, so I know the answer. Now, you've got to find out the answer. Give the organic product or products to the following. And just about everybody's done. All right, let's get to work. What's different? What's not carbon? Ooh, not one, but two oxygens to the same carbon. And both oxygens have carbons on it. Then I have a hydrogen on that carbon, which is this carbon right here. But it could be in carbons, R prime or hydrogen. And I have carbons here, R double prime. We have an acetal or ketal, acid and water, water and acid. What was the carbon with the two oxygens becomes this carbon, double bond to oxygen, a carbonyl. What's attached to it, R prime or hydrogen, and R double prime. And then these carbons on the oxygen become this alcohol. And if you want, you can put a 2 there. So what's R prime? Hydrogen. What's R double prime? And propyl. What's R? Ethyl. So I'm going to start with my carbonyl. What's attached to this carbon? Hydrogen plus 3 carbons, 1, 2, 3. Remember, there's 4 bonds to carbon, and then plus our alcohol, R is ethyl, and that's what you get. Oh, we got to do another one of these, definitely. I made the acid come first here. Doesn't matter what you put first, acid or water. You take this molecule, react it with acid and water, or water and acid. What do you get? Wow, that's a pretty complex molecule. Also, I don't know if I mentioned this, but this whole semester, I've been inoculating you, yes, giving you a vaccine to the chemistry instructor's favorite trick on the test, put a big scary molecule. That's one big scary molecule there. No, it's not. You look for what's different. I think everybody's done, so I'm going to get to work. Is everybody done? I think so. So what's different here? That's better, get it on screen. Ah, an oxygen here, to the same carbon with carbons on it. We have this. Now, this carbon is in a ring. I can do this. And the ring, our prime and our double prime are hooked together, attached together. Well, our prime could have been a hydrogen, it's not. When I take acid and water, water and acid, keep your eye on this carbon with two oxygens, and you get a carbonyl, carbon double bond oxygen. What was attached to it in terms of carbons or hydrogens is still attached to it. And then you'll get your alcohol. And for those who must, you can balance it. I don't. And now here's my carbon, what's attached to it, the ring. That's this carbon here, which is this carbon here, which will be this carbon. So double bond to oxygen, ketone. What's my R group? Which carbon is attached to the oxygen, the end one? So we'll get N-propyl. And what's something you could put down, but you don't have to, the number 2. And that's how you do it. All right, let's move on to an easy one. And the easy one is the following. This most students get correct, but I thought I'd still run it by. Alkyl halide, chlorine, bromine, or iodine is what X stands for. And magnesium, and you get the Grignard. Do not or don't write like this. This is wrong. The magnesium is bonded to carbon and the halogen is bonded to magnesium. Not like this. Wrong. All right. Why don't you try this one? What would be the product or products of the following? Let's see, one person done. Two. I think everybody's done. All right. What's different? What's not a carbon-carbon single bond or carbon or hydrogen? Ooh, a bromine on a carbon. That's an alkyl halide. Remember, X can be chlorine, bromine, or iodine. And we're reacting with magnesium. And what do you get? A Grignard reagent discovered by my hero in organic chemistry, one of them, the great French organic chemist, Victor Grignard. What's my R group? All of this. The carbon with the halogen will be the carbon the magnesium is bonded to. So I have 1, 2, 3, 4, 5 across. I don't break carbon-carbon single bonds, so I have 5 across. This carbon has the methyl, and this carbon is where I had my halogen. Now I have magnesium, and then my bromine. And then there's 4 bonds to carbon. This counts as 1. And that's what you get. Now, let's do the one students always have trouble with. And it's one of my favorite all-time reactions in organic chemistry. Now, keep your eye on the carbonyl carbon. When R prime is hydrogen, it's an aldehyde carbon, it's the ketone. And this attacks that. Remember, I told you organic chemists are violent. We are, look out. And you form something very special, very rare, a carbon-carbon single bond. And what was attached to it, R prime and R double prime, still there. This opens up to an alcohol. Now, common mistake, students think of the first 2 reactions we covered, and they put an oxygen there. Wrong, no oxygen. It's a direct bond to this carbon. And why don't you try this one? What would be the organic product or products are the following? Oh, I just thought of something sad. Usually on a holiday like this, right before the holiday, we're face to face. Dr. White brings in a couple of bags of candy to get all his students on sugar highs. I bring the good stuff in, like Nestle's Crunch or other things, M&Ms in the little bags. All right, I think everybody's done. Let's take a look at this. What's different? Ooh, carbon double bond to oxygen, carbonyl. It's got a hydrogen, but it could have been carbons, but it's a hydrogen and more carbons here. And what am I reacting it with? Ooh, magnesium chloride, and that's a Grignard. Remember, I didn't write it up here, but I'll write it down here. X can be chlorine, bromine, or iodine. And what happens, this attacks to carbonyl. What's attached to that, R prime or hydrogen, and R double prime is still attached. This opens up to an alcohol. No, there's no oxygen here. This is a carbon-carbon single bond to the R triple prime. What's R prime? Hydrogen. What's R double prime? Methyl. What's R triple prime? Ethyl. So I'm going to write this carbon first, which is this carbon. What's attached to it? Hydrogen, R, and methyl. This opens up to a hydroxyl group. What's R triple prime? Ethyl. And that's how you do it. Oh, we got to do another one. I am having way too much fun. Thank you. I ran out of arrow. And there you go. Have some fun. I see maybe 1.5 people done. No, I think everybody's done. All right, let's take a look at this. What's different? What's not a carbon? What's not hydrogen? Ooh, oxygen double bond to carbon, a ring. That's a ketone. Could have been aldehyde, but it's a ketone. Remember, in a ring, our prime and our double prime are connected together. And what's different here? Carbon, carbon, carbon. Ooh, magnesium iodide on a carbon. That's a Grignard reagent. Second step, water and acid, or acid and water. And what do you get? This attacks the carbonyl, opens it up to an alcohol. The arrows show where the electrons are going, in case you're wondering. And this carbon, what was attached to it is attached to it. You get the hydroxyl group, alcohol. And then you do that special thing, a carbon-carbon single bond. And the carbon with the magnesium halide is a carbon bonded to this carbon with the hydroxyl group. So, do you break carbon-carbon single bonds? No. So I'm going to have my ring. I'm going to have my 2 methyl groups here. Here's my carbon here. And attached to that will be, because this carbon right here, a hydroxyl group. Doesn't matter which side you put it on. And what's our triple prime? 3 carbons. And that's what you get. And that's how you do this. All right, any questions? Wow, time flies when we're having fun with ketones and aldehydes. All right, that reminds me. Did anybody happen to drive by a gas station and think the gasoline contains up to 10% ethanol, and that's an alcohol? Or do you happen to go into a liquor store or a place where they sell hard spirits and liquor, like Jewel around my house? But we also have a Binny's, and we also have a Costco. They sell liquor too. Boy, a dangerous place for Dr. White to walk into. But anyways, did you think the beer, wine, champagne, or hard spirits like the good stuff vodka contains ethanol? That's an alcohol. Did you happen to use nail polish remover and look at the bottle and see it's got acetone, and acetone is a ketone? Or, I always wonder why they call it rubbing alcohol. I guess you rub it on yourself. Did you look at a bottle of rubbing alcohol and see it contains isopropyl alcohol, IUPAC name 2-propanol, and that's an alcohol? You should. That reminds me of a story. Do I got a minute for a story? I do. Now, interesting thing about isopropyl alcohol, rubbing alcohol, it's a good disinfectant. And when I was young, up to even college and grad school and past that, before they came out with digital thermometers for you to take at the hospital or your doctor's office, they had glass thermometers with mercury in. Wow, that was dangerous. Luckily, one never broke in my mouth. I wonder, never mind. I don't want to think about that. But anyways, you went to the doctor's office, and the first thing you did when you got into the examining room was the nurse took out a thermometer from this holder. It was V-shaped, sort of like a graduated cylinder, but V-shaped. And in there was the thermometers, usually more than one, in rubbing alcohol. And she takes some cotton, wipe off that, stick it under your tongue and say, I'll be back, 3 minutes, the old thermometers, and come back. And that thing tasted, I mean, it was, I don't want to scare you, I'll do it again. It was awful. And that's my story. And if I look at the clock, let's take another 5-minute break, come back at 2:45, and we'll continue. Time to get back to work. Everybody back? All right, guess what time it is? It's show and tell time. Remember that in grade school when you had show and tell? I don't know if you did when I was, I don't know if they still do that when you were in grade school. Teachers were scared of when show and tell and Dr. White, because I'd bring in science stuff that they had, especially the English teachers, even some of the science teachers in grade school had no idea what I was talking about. They didn't like that. But I figured show and tell, everybody see that? It's 70% isopropyl alcohol, rubbing alcohol. Doesn't say it on here, just says. And if you look at the ingredient label, I don't know if you can see it, it says, I'll help you out, isopropyl alcohol, 70%. They were out of it, but they also have 90% too. And this is good to have around the house, especially with the pandemic. And I have that, and I thought I'd do a show and tell. Now, before I go on, does anybody have any questions whatsoever or any requests for anything on test number 2 or any of the functional groups in test number 2? Going once, going twice. So I've been to auctions when I was in my life. All right, let's get back to carboxylic acids. Uh-oh. Hang in there. I gotta close something and then open it again. All right. Got everything back up and running. All right, we were talking about carboxylic acids. Notice I say we, I was, you were listening and practicing. And just to remind you, a carboxylic acid is a carbonyl with a hydroxyl group on it and an R group. And you name it by finding the longest chain, name it as an alkane, drop the E, and add the letters OIC and the word acid. And the carbonyl carbon is always number 1 when you're numbering, and you don't put that in the name because everybody knows that. Now, the following slide, click the switches. Will this ever be on a test? No. Now, certain carboxylic acids, usually the shorter chain, low carbons, have sharp and unpleasant odors. How many of you also, the smaller MW means molecular weight acids have a sour taste? How many of you have done shots of vinegar? None. Oh, by the way, sour and unpleasant. I was in a lab I managed where one of my chemists dropped the bottle of butyric acid or butanoic acid, and it smelled like upchuck. It's one of the most foul smelling chemicals. It was unpleasant. I helped clean up, and later on, the pants and shirt I was wearing got tossed in the garbage. Ugh. But anyways, lower molecular weights are sour taste. It's polar. I'll talk more about that later. They have high boiling points because they can hydrogen bond. And you'll learn that the lower molecular weights, like acetic acid, are soluble in water. Remember, vinegar is acetic acid, this structure. Nobody ever calls that ethanoic acid. It's called acetic acid. And if you haven't done so, when you have a chance over the 4th of July holiday weekend, pick up a bottle of vinegar or mustard, ketchup, relish, or pickles, and you'll see they all have vinegar in them, which is acetic acid and water. All right, now, why are they called carboxylic acids? And they're called carboxylic acids because they dissociate. I'll show you in the next slide the reaction in water, yielding a carboxylate anion. And in water, you get the H plus reacting with the water to give you a hydronium ion. Now, in case you forgot, from general chemistry, HA is an acid, B is a base, and you have a proton transfer. An acid is something that donates a proton. Which is H plus. And notice the H plus goes to the base, and this is what you get. In real life, this is probably an equilibrium, which I have in the next one, and switch is still off. And notice in a carboxylic acid, the proton comes from the hydrogen on the hydroxyl group attached to the carbonyl. And this goes to the water, and that's why this is called an acid, because it donates a proton. I even have it on the slide. No, the carboxylic acid donates a proton to water and thus is an acid, which is why it's called carboxylic acids. Oh, one thing I should point out, and I'll talk about it later, this right here is called the carboxylate anion. Because if you look here, it has a negative charge. That makes it an anion. Now, switch is still off. What makes a carboxylic acid acidic? And I have a note to myself, note the acidity of ethanol versus acetic acid. Well, let's take a look at this. Switch is still off, but this is good stuff to know. Here, the equilibrium is like this. Which it donates a proton to something, and it does that. It's an acid. Now, ethanol, the equilibrium is like that. On top is the tiniest of the arrows I could draw, essentially none at all. And what you get is this. So why does this hydrogen come off easily and this one does not? Because I can draw a resonance structure by moving the electrons here to here, switches off, but I still want to draw this form. And as you learned in benzene and with ketones and aldehydes, the more resonance forms you can draw, the more stable something is. So this carboxylate anion is more stable than this alkoxide anion because I can draw resonance forms for it that make it more stable. Therefore, it's more likely to want to go there. And that's why carboxylic acids are acids and ethanol is not. If you're reading a book, I'm skipping section 10.5. Remember, this is test 3 material. Click, switches on. And if we have, remember, acid and a base, neutralization, you form a salt. And with a base, and here I'm going to change this a little. Let's do this. You take carboxylic acid plus the base, and sometimes you'll do some water, and I'll forget to put the water there like I did on this slide. And what you get is this carboxylate anion plus water, which you don't have to put down because I asked for the organic products and water is not organic. And M here is lithium, sodium, or potassium. There's other things, but that's what I'll limit it to. So when you react an acid and base, you get the carboxylate anion and the bases we're using plus water. So let's take this for a spin. And if I look at the following reaction, what's the organic product or products? What do I have here that's different? Ooh, carbonyl to an oxygen with a hydroxyl group and carbons. That's a carboxylic acid. NaOH, it's base. I could have put water here. On test, I'll probably forget to do that, but this doesn't matter. And here I can write it this way, where M is lithium. It's not a cation yet. Sodium, which it is, or potassium. And what you get is the carboxylate anion, and the metal here is the cation. And now what's our methyl? Keep your eye on the carbonyl carbon, always good to do. What's attached to it? Dr. White had R on his brain. All right, methyl group is my R, carbonyl, oxygen minus, and sodium plus, and I'm done. Now, let me talk about something that happened a number of years ago in Chem 170. I had a student who I took off points because they didn't put the charge there on test number 3, and he was quite upset. And he said, why'd you take, I don't have to put charge down. I said, if you can prove you don't have to, I'll give you full credit. And immediately he did on a piece of paper, he said, do you write sodium chloride this way or this way? And I said, usually that way. And he said, see, you don't have to put charges. I said, all right, you're right. And I mellowed out my old age. And I said, you can draw it if you want. I'm going to put charges because I think that's cool. But if you wanted to write it this way, I would give you full credit. So I'm mellowing out my old age, and either way, but I'm going to always put the charges. Your turn. Give the organic product or products for the following. 3 points each. I see one person done. Another one. Let's get to work. What's different? Carbonyl, hydroxyl group, carbons, carboxylic acid. What am I reacting with? Lithium hydroxide. That's the base. Remember, M can be lithium, sodium, or potassium. And what do you get? A carboxylate anion plus water, but we don't have to put the water down because I'm asking for the organic products. What's our isopropyl? What's attached to the carbonyl carbon? Guess what? It's still attached. Do you break carbon-carbon single bonds? No. And therefore, I have my carbonyl, oxygen. I put the negative charge, you don't have to. And you have a lithium cation. And remember, there's 4 bonds to carbon. So I'm going to put in my hydrogens. Ooh, let's do one more. There'll be 3 synthesis problems. And what would you react with sodium hydroxide to make that compound? I see one person done. 2. I think everybody's done. So let's take a look at this. Well, I got a benzene ring, but that's not going to react with sodium hydroxide. But I have a carbonyl with an oxygen minus and a cation. That's a carboxylate anion. Remember, M can be sodium, lithium, sodium, or potassium. And what do you start with? A carboxylic acid plus the base. And here M is sodium. And therefore, what's R? My benzene ring. And what do you start with? Benzoic acid, which is the name of that compound. And you react that and you'll get, by the way, I'll teach you later about the nomenclature of this, but this is called sodium benzoate. I'll teach you this nomenclature later, but one of the things I've mentioned in the past, and it's time to do it again, and that is the question, why are you taking this course? And the obvious answer is you want to get into school or program that says you got to take organic chemistry. Why learn organic chemistry? Well, here's an example. How many of you are familiar with the stuff in either the little cans, well, not that little, or plastic bottles or the bigger plastic bottles we in the Chicagoland area call pop? Hope you all are. And if you look at the label of pop, you'll see near the very end, it contains sodium benzoate, which you just made. What is it in there for? It's a preservative. How does it work as a preservative? I have no idea. I'm a chemist. I know how to make it, but I don't know how it works in pop, but it is there. Let's see if I can find something while I got you. So everybody's, oh, let me check, hold on. Does everybody see Dr. Pepper? And here's the ingredients: carbonated water. I'll teach you what high fructose corn syrup is later. And look here, sodium benzoate. And it says preservative. There's also caffeine and other things, but that's in there as a how does it preserve it? I don't know, but I like my Dr. Pepper. Let's try one more just out of curiosity. And here, one of my all-time favorites, which you can get at Jewel, they never sold it at Dominic's, which is no longer here, is Verner's ginger ale. If you've never had it, you're missing something real good. It's a little spicier ginger ale, and it's very highly carbonated. Let's see. Here it is. And I've got about 3 cases in my house because you never want to run out of Verner's. If you haven't tried this, you should. It's good. It doesn't taste like regular ginger ale. All right, let's get back to work. Now, carboxylic acid reacting with a base, carboxylate anion. Now, there's a very special base I'd like to talk about, and that's sodium bicarbonate. Sodium bicarbonate, NaHCO3, is also known as baking powder, which I think most of you have. And this is a special reaction. And let me move us over here. And this is a reaction where I will ask, give all, not just the organic, all the reaction products. If you take a carboxylic acid, remember carbonyl here, react that you get the carboxylate anion, you get water, but you get carbon dioxide that's given off as a gas. This arrow means a gas. So you get sodium bicarbonate, water, carbon dioxide. So let's look at this reaction. And let's, first of all, why does it do that? And first, I'm going to show you something you don't have to write down, but and here's the general reaction. Well, what's happening? Well, this is an acid that gives up a proton. But let me show you the structure of sodium bicarbonate. This is the structure of sodium bicarbonate. And this is like Na plus OH minus, but instead of an H, we have all this. And when you react it with the carboxylic acid, this proton goes over there. And what you get is the carboxylate anion. In this case is sodium. I've never seen any other anion in baking powder. I don't think it exists. And then you get this interesting intermediate that's called carbonic acid. Now I'm putting it in brackets because that means you can't isolate it. As soon as you form it, something interesting happens. Whenever a molecule can break down to something interesting and stable, it does. Now, if we look at this molecule, carbonic acid, notice I have OH here and I have an H here. 2 hydrogens and oxygen, 2 hydrogens and oxygen, all water. And this breaks down to water, and the bond here goes like that, and this makes the CO2. So whenever you have carbonic acid, it immediately makes water and CO2. It just decomposes immediately, which is why you can't isolate it. So that's what happens. Let's try this. And the question is, give all the products, not just the organic, for the following reaction. I'll do this one, then I'm going to let you have some fun. And let's take a look at this. What do we have here? What's different? Carbonyl with the hydroxyl group and carbons, carboxylic acid. Ooh, sodium bicarbonate, baking powder. And what do you get? You get the carboxylate anion of the carboxylic acid plus water, because I'm asking for all the products, plus CO2, and it's given off as a gas, and that's what the arrow means. So what's my R group? This. So I'll get this carboxylate anion plus water plus CO2 given off as a gas. And that's how you do it. Your turn. And that's the ugly looking H that I better fix up. In real life, I can do that on a whiteboard in a classroom. I have to fix it up too. Remember, ooh, I forgot the hydrogen, sorry. Remember, give all the products for that reaction. I see one person done. Another one. And it's time to get started. What's different here? Carbonyl, hydroxyl group, carbons, carboxylic acid. And I've got, ooh, sodium bicarbonate, baking powder. And if I react this, what do I get? All the products. I get a carboxylate anion plus water plus carbon dioxide given off as a gas. So what's my R group? T-butyl. Do you break carbon-carbon single bonds? No. So I'll get this carboxylate anion. This is an oxygen. plus water plus carbon dioxide given off as a gas. Oh, that was fun. Let's do another one. First of all, let me wait a second in case you want to check your answer. And now, oh, let's do this one. Whoops, hold on. And what would be all the products for that? 6 points. Ooh, yeah, well, there's 3 products. Everybody's done. Let's take a look. What do I have that's different here? A carboxylic acid. Carbonyl with an R group and a hydroxyl group, carboxylic acid. Sodium bicarbonate, baking powder. Excuse me. And what do you get? The carboxylate anion plus water plus carbon dioxide given off as a gas. And what's our methyl? So I get this carboxylate anion, which is called sodium acetate, the common name, plus water plus CO2 given off as a gas. And that's how you do it. Now, if you remember the first day of class, I said you'll learn a lot about Dr. White in my class, about my past. Now's one of those times. The reaction you just did has very, very special and good significance to me. Why? Well, I'll tell you. By the way, warning, I'm going to do some artwork, so be careful. Don't laugh too hard when I do my artwork that you bust a rib. Be careful. But when I was little, and I mean little, like about 5, 6, my father started teaching me chemistry. I wonder why I became a chemist. Don't know. But anyways, one of the things he taught me, but before I tell you that, back then when I was about 5, 6, the big thing happening in the United States and the world, but especially the United States, was the space race with the evil Soviet communists. And we were in a big space race. We were the ones who finally won it by getting to the moon first, but it was pretty significant throughout the whole country. And anything that had to do with space and rocket ships, little boys loved and wanted to get their hands on. Now, back then they had a candy that was sold in this little tube with a cap. And watch out, warning, I'm going to do some artwork. And does everybody see my whiteboard? It had a tube, and then it had a cap on the bottom, and it had 3 fins. And it was only about 3 inches tall. And inside were these little beads of the most god-awful candy you've ever tasted. How do you know that? Because when you see a 5-year-old get one of these, open it up and dump the candy into a garbage can, you know it's bad. Well, when you empty it out, this tube up here, if you turned it upside down, was like a little test tube. And my father showed me, if you put some vinegar in there, and then some baking powder, slam the cap back on, hold it by the fins, and shake it and hold it like this. Hold it by the fins, and the cap would build up pressure and go boom and shoot off like a rocket ship. And that was so much fun. Why did it do that? Well, let's find out. Well, what's vinegar? It's water and acetic acid. What's baking powder? Sodium bicarbonate. And therefore, as you learn from the reaction we just did, when you mix those together, you get the carboxylate anion, which is not what's important here. You get water, that's not important, but you do get, and this is important, carbon dioxide given off as a gas, and it builds up in here, and that's what causes the cap to shoot off, or the tube to shoot off, because the pressure from the gas builds up enough that it shoots off like a little rocket. And if your timing is good, you can shoot it off to about, oh, I'd say at least 6, 7 feet. And my timing got really good. Now, I should warn you, back then when I was 5, my best friend, who I haven't seen in decades, he moved out of state and we lost contact, but we were really good friends. Dickie Gale did something very bad. He used up all his mother's baking powder and didn't tell her, because he did it with me. We were doing it outside. We could spend an hour doing this or more. And then when she went to bake, she went to get her baking powder. It was an empty can. Oh, did he catch it? So if you ever use up all your mother's baking powder, guess what? Tell her it's out so she can buy some and have it when she needs it. Because otherwise you'll catch it. You don't want it. Oh, did he catch it bad? Ooh, I hate to think of it. But anyways, that's the first thing. Now it's time for me to tell you a secret from Dr. White's family. And that is, my father loved to cook, great cook, better cook than my mother. And she was an excellent cook. And times when he had time, because he owned a drugstore and he was only home on Sundays, some Sundays he'd say to me, we're going to cook tomorrow on Saturday. And he'd tell my sisters and mother, tomorrow is men's day, cooking out of the kitchen. And we cook. And we had a huge freezer, so we'd fill up stuff in there. One of the things I loved to cook with him was spaghetti sauce. And he could make really good pot of spaghetti sauce. We're talking, we had a big pot and we'd make about 3 gallons, put it in plastic containers and freeze it. My mother liked that because dinner was take those out, defrost it the night before, and she just poured it in a pot. He'd make meatballs too on the side. We'd have those and make some spaghetti, and dinner was easy. What did he do that was special? Well, spaghetti sauce has tomato sauce and tomato paste. And tomato paste has citric acid in it. Tomatoes have citric acid in it. And that gives it a very sharp taste to it. If you've ever had ketchup on something, it had a canker sore, you know how it burns in your mouth? Well, that's because of the citric acid. I don't know, I've never asked my father how he came about doing this, but one of the things he did was, don't forget, we have a couple gallons of this. You have the citric acid, let's call this HA. And the sodium bicarbonate. And this neutralizes acid-base reaction to get the carboxylate anion, sodium citrate plus water, and CO2, which is given off as a gas. What this does is it increases the pH, makes it less acidic, less tart, and it's really nice and mild. And when you do this, you cut back on the salt because this also tastes salty to your tongue. So you just cut back a little on the salt that you put in the spaghetti sauce. And he had other things, seasoning, garlic and stuff like that. But at the very end, he'd put in about a tablespoon of this. Don't forget, we're talking about a big pot, maybe a tablespoon and a half. And you'd see this white foam on top. And you know you were neutralizing the citric acid, and it made it much nicer, milder, smooth. I don't know, smoother is the right term. Where's one of those people from the Food Channel with all their new adjectives about what food tastes like? Now, the other thing, I don't know where he found out, if you've ever made your own spaghetti sauce, you know how it doesn't taste like the really good stuff at the expensive restaurants? And somehow he found out in a big pot, you just put a little pinch of cinnamon. Yes, cinnamon. And it makes it taste just like the real good, expensive stuff in those very fancy restaurants. And don't put a lot. We're talking a couple gallons, like a half a teaspoon. I had a friend of mine, I told him that. He was making a small pot. And he put like a teaspoon in there. He called me up and said, I can't even taste the tomatoes. It just tastes cinnamon. I said, you put too much. I told you, just a little bit. All right. Now, another part of that story. I taught that in the past at Chem 170 class. I've done it for a while. And a couple weeks or a month later, one of the students, she came up to me after class and said, my father and I would like to thank you for that tip you taught us of what your father did about baking powder and the cinnamon too. I said, well, you're welcome. What's so important about it? She said, you don't know, but I and my father suffer badly from acid reflux. That's where some of your stomach acid goes up your esophagus and can be very painful, I've been told. I worked at a company where another manager had it so bad, he had to have an operation to sort of stop that. I mean, it was really bad in this case. And the student said, we love spaghetti sauce on things, you know, and spaghetti. But whenever we had that, my father and I would suffer from the citric acid, because I taught him about citric acid from the acid in the tomato sauce. Well, now when we put in the baking powder, it neutralizes a lot of that. It's not as acidic. And guess what? We're not in pain afterward. And I thank her for sharing that story. Now, another story, in your stomach, you have HCl, but it's a quick one. A student of mine afterward, when I taught that, you know, how you acid plus sodium bicarbonate makes carbon dioxide. She said, well, my grandmother was from the old country. Whenever she got an upset stomach, she'd take a couple teaspoons of baking powder, which neutralizes the acid in your stomach. But afterwards, she'd always be burping. And I said, well, that's because it makes CO2. If you don't know, most of your burp, when you burp, is carbon dioxide. See all the neat things you're learning in my class about Verner's? And as I mentioned earlier, special carboxylate salts, sodium or potassium benzoate, it's mainly sodium benzoate, is used in a preservative in pop. Now, why do I have potassium? A number of years ago, when it was in the news, you got to check your sodium level, which they means the cation, sodium plus, in your intake of your diet to keep your blood pressure down, which is true. My doctor told me I better get that and a couple of things down a couple of years ago, or I'll be dead in 5 years. It's been more than 5 years because I took his advice. But a couple of years ago, when that was in the news and everything, one of the soda producers, pop producers, came out with a low sodium pop. How did they do that? They replaced some of the sodium benzoate with potassium benzoate, which doesn't have a negative effect, I think, on your blood pressure. And that's why they could say it was low sodium. Nobody bought it and you don't find it anymore. Now, how many of you like to go to the supermarket and buy bread or go to a bakery and buy something, come home, and the next day or day after you use the bread or the bakery goods, and there's no mold growing on it, no icky black or green stuff. That's nice. How do they do that? They add a preservative. And the preservative there is called calcium propanoate. And the switch is off for this, but the structure of calcium propanoate, and I'll teach you about how to name things, but calcium propionate is a -1 and calcium is a +2, and therefore it's in a bracket. You have two of these whenever you want calcium. And calcium propanoate somehow inhibits mold growth in bread and bakery goods. Why? I have no idea, but it does. And one last thing I want to talk about. How many of you have heard you should get your daily calcium intake so you have strong bones and you don't get osteoporosis, which at older age people, it's a problem. It's a sad problem, where they're stooped over and sometimes anyways, how do you get calcium? It's not calcium metal, because that's as hard as my gold ring. And it wouldn't do good for your teeth. What calcium are you taking? Calcium cations, Ca+2. And what is the most common way to do that? It's calcium citrate. And calcium citrate So everybody see calcium citrate on the screen? Thank you. It has this structure, and because it has three carboxylic acids, two of them, or all three of them, it's more complex, is associated with the calcium. So this carboxylate anion, actually there are three of them in the molecule, with this calcium cation is how you get calcium in your body. And the best one, I think personally, I take supplements, is Citracal. I like it, and my bones are still doing good. All right, for the 4th of July holiday, I'm going to have a special request of all of you. I'm going to shut off the recording. And Gang Gesund, have a great 4th of July. Bye. Don't forget, 4th of July.